Hello guys, so today our topics are about the macromolecules as a cooperative system, the coil and the globule, methods of investigating of macromolecules and polyelectrolytes. So speaking about the macromolecules, we have already seen that the state of conformation of a given link of a macromolecule depends on the state of conformations and their adjacent links, and a system which states the elements depend on another, which is called cooperative. And the concept of cooperativity was first introduced by Fowler while he was studying the phase transitions. And the and it cannot be understood without the phenomenon between the elements of system. For example, the gas liquid transition is a cooperative transition. So for that equation, the gaseous liquid and the gaseous and the liquid states are van der Waals equations of the state. And the van der Waals, we all know van der Waals equations means P plus A by V2 into V minus B, which is equal to RT. And this A, this B, and this R are always the constants, okay? And the decrease in the volume is V, which enhances the mutual interaction of molecules, which are A by V square, which are these, okay? So these causes decrease the volume in the causes, okay? And the cooperation of large number of particles lead to sharp transition, which proceeds according to all or none principle. So about that, the calculation of the rotameric partition function is reduced to find the maximum root of the matrix, which is lambda 1, and the value of z is known as equilibrium characteristics of macromolecules. This method is employed to find mean square length of the coil, which is h square, and it is the correlation to rotamer. So rotamers, which rotamers I'm talking about, the rotamers will be E is equal to 2E. And we write this condition like E I J is equal to E I J, and which is equal to 0, which means only in cases if I is equal to J plus 1 and if I is not equal to J plus 1, okay? So these are the small examples which I can give you. And the measure cooperativity is the quantitativity, that is E by KT. In the absence of cooperativity, that is A is equal to 0, and the formula will be H bar is equal to N L tan HB is equal to N L tan H F L by KT. So these formulas, they have many formulas. We can speak about one where the mean, cosine, and angle between two neighboring arrows is taken into consideration. The main form of formula of this is H square bar is equal to NL square plus 2 by N. I is equal to 2. And this we will write I minus 1, J is equal to 1, which will be equal to, I will write it downwards because it is a long formula, which will be equal to NL2 1 plus N divided by 1 minus N plus 2L square N by N minus 1 by 1 minus N whole square. Okay, so these correlations determined by the advantage of parallel arrangements are the arrows which extend the chain, and the conformational transitions of macromolecules, both melting of crystalline and polymer on an extension of chain, which are cooperative. This is important for the understandings of biopolymers. Okay, so next we have the coili and the globule. So what is coil and the globule? The primary of chemical structure of macromolecular chain is fixed. The chemical bonds that do not exchange places, and this means that the equilibrium state of the chain is in fact the state of the partial equilibrium, which fixed linear memory, which Lifshitz. Okay, I'll write it. So the presence of linear memory is the factor responsible for certain features in the properties and structure of macromolecules, and simple calculations of the coil size do not take into account these effects which I was talking earlier, and nevertheless such calculations may be compared with experiments, which is called Flory O point. But we'll write O like this. And it is defined as the temperature at which attractive forces in a given solvent compensated by the repulsive forces and no volume effects are present. So the theta temperature is similar to boil point of a real gas, which is at T will be higher than this. So repulsion predominance is a good solvent, and when T is less than this Flory point, these predominant attraction will be at poor solvent. So this coil is dilated and contracted. So macromolecular coil as a method of fluctuating system is characterized by density correlation, which means density correlation means a quantity which releases a change in density at one point in space occupied by the coil to change in density at another point, which turns out that the correlation of radius, that the correlation is of same order as the same of the coil, and the presence of large correlation radius is due to exactly the linear memory in the chain. But if this is so, then the density of coil is not the thermodynamic characteristic, which means it has no reliable constant value. In other words, we can say the macromolecular coil is continuously fluctuating, and its fluctuations are macroscopic. Only the time average density of the coil has meaning. So what is Flory theory? Flory theory regards to a polymer coil as cloud monomers, neglecting their union into a single chain. It is, however, necessary to deal with monomer and monomer interactions with between chain portions. In other words, it means it can be depicted as a cloud of quasi-particles, quasi-monomers, which are collectively present as the properties of all monomers in the chain. So this theory was proposed by Koklov, and this phase transition is coil into globule. It will be like this, coil to globule. And the state of globule depend on the properties of the polymeric chain. If the chain is long and flexibility is low, which means if it will be like this. So where the P2 means square distance between neighboring monomers in the coil, and R is quantity of the order of the radius interaction between chain lengths. Okay. So in all these, it will be like this, which we already discussed. And the phase transition is a transition where first order of the transition will jump into a density. If the chain is flexible and there occurs a smooth phase in transition of the second kind, which is second order phase transition, accompanied by a gradual swelling of the globule up to a size of the coil, this will be there. Okay, this will be there. So the globule itself is a two-phase system consisting of a compact core and a fluctuating fringe, which means its density fall off gradually to zero. So it should be stressed that the theory at present is restricted to reconsideration of a homopolymer chain built out to identical monomeric units. That's all for this topic. So next we'll go to the methods of investigating macromolecules. So macromolecules of any chemical structures are characterized by definite molecular weight or by molecular weight distribution, and when being in form of coil or globule, which means by their size and shape also it will be considered. We shall consider the methods of experimental determination of these characteristics. Okay, so first we'll write the osmometry, which is based on the measurement of the osmotic pressure, which will be write as POSM. it is of a polymer solution according to Van 't Hoff's law. We'll apply this law here, and this will be P osmosis by C is equal to RT by M. Here C is the solution concentration, gram by centimeter cube. M is the molecular weight of the polymer, and this is the number average molecular weight. Okay, so according to this, for this is for the ideal solutions, and for non-ideal solutions, it will be P osmotic is equal to RT by MC plus BC square plus CC3, and it will go on like DD4 and E5 like this. The coefficients B, C, or whatever we write, they are the Weidel coefficients for dilute solutions. The third and succeeding terms by neglect a plot of P osmosis against C, which is linear and allows us to find this M and V. Okay, so these sedimentation methods consist of sedimentation of macromolecules under the action of centrifugal force and ultracentrifugal force, which rotor the resolves of the speed up to 10 raised power 4 minus 10 raised power 5 RPM. And the centrifugal acceleration is much greater than this force of gravity per minute, and which is like 350,000 grams, which will be 70,000 revolutions per minute. And the sedimentary progresses is zone, its boundaries displaced, and velocity of travel of the boundary towards the base of the cell, which is from axis to rotation, and the rotor is measured. Okay, moving forward, we have polyelectrolytes. Okay, so many macromolecules, including proteins and nucleic acids, are macroions in aqueous solution carrying a multitude of charge groups. We will take the example of methacrylic acid, which will be like this: carbon here with no linked, and here we'll write and CH2 with no chains linked here, which is whole divided by N. Okay, it contains a pollination in polymers, and biopolymers are polymers, that is, they contain both anionic and cationic groups. Proteins contain acidic, which is glucose, and basic, which are arginine. It residues as a nucleic acid that contain acidic phosphate groups and the basic groups, which will be these HN and H2, and these are of all of nitrogenous bases. So they exist as solid microions, which is globular proteins, and flexible polyelectrolyte chains. Evidently, these properties are such macromolecules depend on substantially in the interactions of charges present in them, and the magnitude of these charges depend on the degree of dissociation of iogenic groups in the atmosphere that surrounds them. So coming to the graph, the dependence of the radius of gyration and micromolecules of polymethacrylic acid in the degree of dissociation of the carboxyl groups will be defined by this. We'll make a graph here. The R and the N will be here, and the alpha will be here. So like we'll write here 60, 40, 20, 0 eventually. And here we'll write in points like 0.2, 0.4, 0.6, and 0.8. It's a rough diagram. So it will be like this. So when it is at 0, it will be nearly like 0.1 because it's between 0 and 0.2. When it's at like 40, it will be near the 0.4 alpha. When it's at 60, likewise it will be at 0.4 or between 0.4 and 0.6. So in this solution, it can be obtained that through the use of isoionic dilution, the polyelectrolyte solution is diluted by salt solution with the ionic strength equal to the ionic strength to the most concentrated polyelectrolyte solutions. So the electrolyte properties of proteins make possible that the separation and investigation of their proteins will be by electrophoresis. And if a solution containing charged particles is in an electric field, it particulates moves towards the respective electrodes, and the electrophoretic mobility of a protein depends on the net charge of its molecules, which will be given values at the pH and ionic strength. So special electrophoretic methods have been boundary method or frontal electrophoresis are concerned with the determination of the distance which is traveled in electric field by the sharp boundary, which will be between the solution of the substance under study and the solvent. For the preparative separation of the property mixtures and the solvent, this is used the method of zone electrophoresis. So the solution of the compound to be studied is first place the narrow layer between two layers of the solvent for a sufficiently long period of time. Compounds having different mobilities move apart. It will move apart to a considerable distance, and their zones will no longer overlap, and the separated products can be extracted from the solution. So when we have this separation, the separation is hampered. This can be hampered by the convection transport of the zones, and convection is reduced to a minimum using of support porous medium. Supporting porous mediums will be will take gels or papers or filters, etc., to stabilize the system and to use it successfully, made of a density gradient. So electrophoresis in this case, case we took, is conducted in a vertical tube containing a buffer solution whose density increases with the density gradient. And in case of sedimentation and diffusion, the recording of electrophoretic pattern is made by mean optical methods, and the resulting electrophoretic patterns will be consisting of series of peak corresponding to the various components, which is here as a mixture, and the peak area characterizes the amount of the corresponding component. So that's all for today. We'll continue after some time.